today we're going to have a video about writing equations from real-world application problems. And so at the top of this page, you see all of the equations that we have been talking about over the last few weeks. And our process is going to be to sketch a graph, labeling our axes, indicate what type of function it is. That means, so function type is this type of question right here, linear, absolute value, quadratic, or exponential. Then we're going to write an equation that models the situation that we're given. And then we're going to use that equation to answer the question that's being asked. And we're going to label our answers with whatever units we're given. So I'm going to zoom in here on the bottom half of the page. For this example, it says, due to a drought, the canal from a reservoir is opened so that the reservoir is lowered to meet the irrigation needs for farmers. The level of the water is being lowered by 15 feet per day until it hits the lowest point at 85 feet after 5 days. Then the water level begins to rise at the same rate it was being lowered. What will the water level be after 7 days? So that's what we're going to answer down here at the solution. But first, we have to decide what type of function it is and what's the equation for that. So I'm going to highlight some key information here. We know that it is being lowered by 15 feet per day. That is a rate of change. So we have a rate of change here that is 15 feet per 1 day. And it lowers for 5 days, and then it's going to be at 85 feet. And then the water level begins to rise again. So if we just think about what that shape would be, we have water that is, or a graph that is lowering. It starts at a spot and it's lowering, and then it's going to rise again. So, and it's happening at a constant rate. So it's decreasing at 15 feet per day, and then it's increasing by 15 feet per day. So this is just kind of a rough sketch. And so we don't know what the water starts at, but we know down here that this is 5 days. And so along this axis is our number of days. And along this is the depth of the water. And the depth, the lowest depth that it gets is at 85 feet. So we can see from the shape of our graph and just recognizing that it is going up and down 15 feet per day, that's a constant rate of change, increasing and decreasing or opposites, that this is an absolute value function. And the equation is going to be, it's opening up, so it's going to be a positive 15. And then our vertex, 5 days and 85 feet. And we're putting this in this order so you can see that because we graph time along the x-axis or the horizontal axis, that's why it goes in the first position. So we have x minus 5 plus 85. And of course, we have opposite of positive 5, so it's negative 5 because it's inside the brackets. On the outside, it stays the same, so plus 85. And we're going to use this equation to solve for what happens when we're at 7 days. So that's our x value. And we're going to find our y by taking 15 times the absolute value of 7 minus 5 plus 85. And most calculators don't have an absolute value, a button that you can easily find, so we'll simplify this together. So the absolute value of 7 minus 5 is 2, or the absolute value of 2 is 2. So we're going to, once you take the absolute value, which is just the distance from 0, so if it's positive, it stays positive. If it were negative, it would stay negative. That becomes 2, and we can replace our absolute value brackets once we evaluate the absolute value with just regular parentheses, and that's multiplication. So this would be 30 plus 85, or 115 feet, because that is the depth of the water after 7 days. So 115 feet. And we would put, looking at where that would be, it would be above 85. That makes logical sense with our little sketch here. So you're launching rockets in science class. The rocket is 6 feet tall. So at the time of 0 seconds, the height of the rocket is 6 feet. After 1 second, the rocket reaches a height of 118 feet. After 2 seconds, the rocket reaches a height of 198 feet. After 3 seconds, the rocket reaches a height of 246 feet. 246 feet. After 4 seconds, the rocket reaches a maximum. This is a key idea here. I'm going to highlight that. That maximum is 262 feet. What is the height after 7 seconds? And again, that is what we're finding down here, that when x is equal to 7 seconds, we're going to solve our equation to find y once we figure out what that equation is. Hopefully when you read through this, it makes you think of putting together a table. They give you a bunch of data points with our x and y, and our x is seconds, and our y is feet or height. So time versus height. So fill in the table with the information from the problem. So we have at 0 seconds, it says right here, after 0 seconds, the height of the rocket is 6 feet. So 0.6 is our first point. Our next point, 1 second, reaches 118 feet. You're going to put that in the table and so on. Once you've put these values in the table, I want you to circle that maximum, which happened at 4 seconds, because we know that that is going to be our turning point. So if we have a graph with a turning point, or a situation with a turning point, we know that it is either exponential or quadratic. And this is, if you've ever seen something thrown in the air, it is not happening exactly straight up and straight down. It happens in a curve, and that makes this quadratic. Any projectile is going to be a quadratic function, and we can see that by finding the differences in our table. So let's do that now. And if we subtract 118 and 6, we're going to get that this is increasing by 112 from 118 to 198 is increasing by 80. 198 to 246 is increasing by 48. And 246 to 262 is increasing by 16. And with quadratics, we know that we need to look at the second difference. And so let's do that by finding the difference here. Here I'm decreasing. 112 minus 80 is negative 32. 80 minus 48 is negative 32. And 48 to 16 is also decreasing by negative 32. So we know that our rate of change is decreasing by 32. And we know that our A value is the rate of change divided by 2. So that's going to be negative 32 divided by 2, or negative 6. I'm going to do a quick sketch of our situation. We know we don't start at 0. We start at 6 feet, and our object is going up and coming back down. We know this point right here is 4 and 262 feet. So at 4 seconds, we're at 262 feet. So that would be the height right here at 262. So this is feet, and this is seconds. And so let's take a minute to label here, and this would be 4 seconds. So this is just our quick sketch here where we have our starting point at 0.6, our maximum point at 262 feet, and it's going to land somewhere over here. So we have enough information now to write our equation because we have our A value and we have our vertex. So it is going to be y equals negative 16, which makes sense because our U shape is opening down, x minus 4, don't forget your square, plus 262. And now we're going to use that information and plug it into with 7, because that's what the question asked above. We wanted to know what's going to be the height at 7 seconds. So we have negative 16, 7 minus 4 squared plus 262. You can actually put this whole thing in your calculator with parentheses and all, including your square. Sometimes a calculator will have an x squared button. Sometimes you have to use the caret button. and then a square, but you will be able to put this whole thing in your calculator and you will get 118 feet. Try this now. If you don't get 118 feet, ask for help in showing how to put this into your calculator. I shifted down a little bit to question 3. The population of microbacteria starts at 1 gram and quadruples every day. What is the population after 10 days? When you see this quadrupling or tripling or doubling, that is a factor, that is a multiplier. So I'm going to highlight this. So when we have a factor or a multiplier, we are talking about an exponential function. And we are multiplying by 4 each day. I think it is helpful to think about this with a table, which means at 0 days. So our x is the number of days, and so our time, and our y is about the bacteria, and we're measuring that in grams. And so at 0 days, we have 1 gram of bacteria. At 1 day, we are multiplying by 4, it quadruples. So we now have 4 grams of bacteria. At 2 days, we have to multiply by 4 again. 4 times 4 is 16. At 3 days, we are going to multiply by 4 again. And that's 64. You can see we're getting big pretty quickly. And we're probably not going to want to plot more, but just to see what's happening on the graph, 64 times 4 is 256 grams. So it's going up really quickly. That makes sense for our exponential function. So if we think of our graph, our multiplier is 4. So this is going to be a growth graph. It's going to look something like this. And we haven't really talked about where the tail would be. But if we think about the graph, so go over to your graph and label your number of days and number of grams. And let's put a scale on here. We'll just make each tick mark along the x-axis or our time axis go by ones. For our horizontal or vertical axis, our y-axis, I think we'll go by tens, spaced out a bit like this just to get a few of our points on here. With exponential, it's hard to graph a lot of points. So our first point would be, way down at the axis and at 1. So we'll put a point right here. At 1, we're just at 4, so we're just about halfway in that. At 2, we're at 16, so we're not quite to 20 yet. And then at 3, we are at 64, which is way up here. And so you can see if we just connect these, where do you think our floor is going to be? Our floor is actually here along our x-axis, which is at y equals 0. So that means our k is 0. So we don't have any part of k, but we do have our multiplier. And our equation would be y equals 4 raised to the x power. You could put plus 0 if you want, but you don't need it for our equation. We want to know what happens after 10 days. So when x equals 10, what is our y going to be? It's going to be 4 to the 10th power. And you're going to need to do that in your calculator. It is often you use that little caret key. Some of your exponent keys look different, but you put that in, 4 raised to the 10th power, and we're going to get a really big number. We get 1,048,576, and that would be grams for our unit. And we'll put that here on the line. 1,048,576 grams. So looking at the last problem on the page, you have $30 in your bank account. Every day you spend $4 on snacks from the vending machine. How much money will you have after 6 days of snacks? So we're spending the same amount each day. That's a constant rate of change. So let's highlight that right here. So this is our rate of change, and it's not changing. Every day we're spending $4 on snacks. So let's put together a quick sketch here. So I put in a scale. You really don't need to even do this. We know at the top, the most money we have is $30. And so along our y-axis is the amount of money, and I'm labeling that in dollars. And along the x-axis is the number of days, and I've put 7 days here. We want to find out what it's going to be at 6 days over time. So I know that my first point is going to be here at 0 days, I have $30. But every day, if I, on one day that I spend $4, I'm going to go down. I'm not going to go down quite what I put on my scale, but I'm going to go down a little less than 5. And I'm going to keep going down at this rate. And we want to see where we fall. So it's going to be a line that is with a negative slope here. And we're not sure where it's going to fall. And I didn't do a good enough scale to know if it is going to happen at 6 or 7 or where we're going to hit, but we're going to solve this because we can write our equation. So we know that this point would be 0, 30. This point would be 1. And then if we take 30 minus 4, that is going to be 26. So we can use any of those points when writing our graph, but we should know that our slope is, or our rate of change is, that we're decreasing $4 each day. So our slope is going to be negative 4 over 1 or negative 4. So this is a linear function because it's a constant rate of change. And my equation is going to be y equals negative 4 x minus 0 plus 30. And we could put this in slope-intercept form too if you want, or simplify this, y equals negative 4x plus 30 because x minus 0 is just x. And so we want to find out what happens when we get 6 days. So we would have to go to our equation, y equals negative 4 times 6 plus 30. So negative 24, or you can think of that as 30 minus 24, but you're left with 6. So you have just $6 left after buying a $4 snack each day.